I've just done one method and it has taken me 2 lessons. For the moment, I left the formula there. So, in the last lesson, I posed a question at the end of the lesson. What if the derivative is not a constant? For example, suppose you had an integral 2x minus 1, 2x squared minus 1 power 4 dx. When you differentiate, this resembles x power 4, perfectly correct. But unfortunately, even though it resembles, its derivative is not a constant. 2x squared minus 1 power 4, because when you differentiate this, I get 4x, which is not a constant. So I can't say, you cannot say this, power 5 over 5 times 4x. Number 1, x is a variable and it can take any value. Then at x equal to 0, the function is not defined. Your answer is rubbish. Secondly, if you want to use u over v to differentiate, see if you get this. You will not get it. That means that method is wrong. So that's the reason why in the first method I always insisted you need to confirm that the extra, even though it resembles a formula, the extra function gives you a constant on differentiation. If this was only 2x minus 1, I could have done it. So, to be honest, this question can be integrated. This question can be integrated provided you expand 2x squared minus 1 power 4. Well, what if it was a power quarter? What if it was a power 402? Boom. So when you apply a method, it has to be applicable everywhere. Whereas, suppose I had an x dx there. So this is, I will put it as inspection. Of course, a word of advice to some of you, they say, that's why I call it a method 2a. Method 2b, I will show you substitution. So it's up to you whether you want to do inspection or you want to do substitution. But if you want to do inspection, you have to show certain steps. If you want to do substitution, you have to show certain steps. And the syllabus clearly says students are expected to know simple substitution. This falls under the category simple substitutions. So I compare the question with the standard formula. It seems to be of the type x power n, but there is an extra function there. And when I differentiated this, I didn't get a constant. Okay. Now, which is the more complicated function here? 2x squared minus 1 power 4. What is d by dx of 2x squared minus 1? 4x. This question has an x and the derivative is 4x. Yeah? Should I do it the other way around? I think I should do it the other way around because some people might get confused. So I will make part A a substitution, not given. There are questions where substitutions will be given. Okay. Then is 4x. What do I have here? X. That means I know I have a dy by dx. If I were to call this as y, I would have dy by dx. The difference is only a constant. Suppose I call u equal to 2x squared minus 1. Yeah. What is du by dx? 4x. Okay. What you do is, oh my god. So in other words, you compare the given question with a standard formula. The x function is 2x squared minus 1. When I differentiate 2x squared minus 1, I get 4x, and the question has an x. Then we say we have a function which is 2x squared minus 1 and its derivative which is 4, I'll put that in brackets, x. You look at the variable x is there and I have the variable. So the question has a function and derivative. Whenever a question has a function and its derivative, you can use substitution. So substitute. So you say let u equals that. That means I can substitute that for u power 4, correct? But remember, if I write u power 4, I can't integrate with respect to x. Remember I told you in the beginning, if you have u, it should be du. If you have y, it should be dy. If you have donkey, it should be d donkey. So therefore, from here, what is dx? Dx is du over 4x. Substitute there. So what do I get? U square x du over 4x. Yeah. Look, we have inbuilt security system in maths to help you get your 100% a star. What do you see? Quarter integral u squared du. Now, isn't that a straightforward integral in u? There is no x and this resembles the formula. So it becomes quarter u cube over 3. But my question was in terms of x. Your answer is in terms of u. So convert u back to x. So that's a 1 over 12 times 2x squared minus 1. Oh, that was a power 4, was it? Oh my god. Okay, let me change it as squared because I don't want to go back. So power cube plus. Yeah. So if substitution is not given, you have to look whether you can use substitution. In which case, look at the question, see what is the complicated bit there, whatever is inside that complicated bit, differentiate it, see if the variable you get from differentiation is in the question. That means you're looking for a function and its derivative. If it is there, you call the function as u, find du by dx, make dx the subject, substitute for the function, substitute for dx, leave everything else as it is. When you substitute, if you are correct, built-in system security, I told you, if you are correct, you should get a simple integral in u. Integrate, don't substitute there, then you are back to square one. Integrate, get the answer. After you get the answer, substitute back, and please don't forget to stick a plus c in the end. I'll take examples, another 1 or 2 examples. Yeah. Suppose I had integral sine cube 2x cos 2x dx. Well, I can't integrate directly, obviously, because it's not there. So what am I looking for? A function and its derivative. The complicated function is sine cube. So when I differentiate a sine 2x, I get a cos 2x. Good. But the problem is, when I differentiate a cos 2x, I get a sine 2x. So why can't I look at it that way? But then, the more complicated function here is a sine because it's a cube. So look for the derivative of, I can't say complicated, that comes a common sense, but I'm just giving you a hint. So the more complicated function is sine 2x. So you know when you differentiate sine, you get cos. You have identified, so you identified a function and its derivative. Call the function as u, not the power. If you differentiate the power, no, it doesn't work. u is sine 2x. Find du by dx. Sine 2x gives you cos 2x. Remember, you are differentiating. Onion rule. 2x gives you 2. Make dx the subject is du over 2 cos 2x. So write the question integral. In place of sine 2x, I can write u. I don't know anything about cos 2x. I keep it as it is. In place of dx, I can say du over 2 cos 2x. The cos 2x and the cos 2x cancel. Don't I get half integral u cube du. Very good. What does u cube give you? U power 4 over 4. So it's 1/8 of sine power 4 3x plus c. So this is called simple substitution. That means you're expected to do this. Please don't say sine cube gives you cos cube, cos gives you sine, so it's cos cube 2x, sine 2x, and even divided by 2, because you remembered onion rule. Doesn't work that way. Okay? I'm going to take the next one because it's very important. Integral x power 5 over 2x cube minus 4 dx. Sir, life became so complicated suddenly. When I differentiate x power 5, I'm going to get x power 4. I don't have any x power 4. When I differentiate 2x cube minus 4, I get 6x squared. I don't have an x squared there. What do I do in this case? What do I tell you always? God has given us the brains. Alright? I need an x squared to use substitution, correct? So therefore, and always whenever it's a fraction, you look at generally, unless it's an ln, the derivative of the denominator. The denominator is 2x cube minus 4. So this is my thinking. That's why I'm writing it. You don't have to write it this way in the exam. I need an x squared, right? What do I have here? Oh, let me make it x cube minus 4. Why bother? 3x squared. I have x power 5. I need an x squared. What happens when you remove an x squared? Don't you get an x cube? So can you write it as x cube over x cube minus 4 times x squared dx. Whether I differentiate that or that, I still get an x squared, don't I? And as I said, always get rid of the denominator, not the numerator. So if I have to call u equal to x cube minus 4, du by dx is 3x squared. So dx equal to du over 3x squared. I don't know what is x cube. I know that is u times x squared. I don't know. Dx is du over 3x squared. I can cancel the x squareds. So I have 1 over 3 integral x cube over u du. Fundamental rule. You can't integrate x with respect to u. You can't integrate u with respect to x. You have to integrate with respect to u. I have an x cube. I can't integrate x cube. It's not a constant, so I can't take it out. What do I do with x cube? From here, what is x cube? U plus 4. So it becomes integral u plus 4 over u du. Integral u over u plus 4 over u du is integral 1 plus 4 times 1 over u du. Integral 1 gives you u plus 4 times 1 over u gives you ln u plus c. So what is your u? So x cube minus 4 plus 4 ln x cube minus 4 plus c. In the exam, they will say, show that it is x cube plus 4 ln x cube minus 4 plus c, or x cube plus ln x cube minus 4 power 4 plus c. That means, what is that minus 4? A constant. What is c? A constant. What is c minus 4? Still a constant, right? So any constant, standalone constant, can be absorbed by c. So I can say x cube plus ln x cube minus 4 power 4 plus c. If you don't want to write plus c, write it as plus k, it doesn't matter. So in other words, sometimes it looks as though there is no substitution, but there is a substitution, right? So that's the method of substitution. And as I said, I have taken 2a substitution not given. Yeah. In the next lesson, I will show you a shortcut to this, but even though it's a shortcut, it's not easy to see. Yeah. But if you can understand it, if you can click it, that saves you all this working. Okay. I'll show you in the next lesson. I'll see you later. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.